Hi class, so I know you may be expecting a presentation on a multimedia principle, but before we begin, we're going to learn some Japanese. I have no idea as to how many of you watching this video has studied Japanese, but today I'm operating under the assumption that the majority of you have either little or no previous experience with this language. If you do, I apologize. However, we're going to learn to identify different colors in Japanese. So, let's practice pronouncing them. Please repeat after me and pause the video if necessary. So, repeat after me. Aka, ao, ki, midori. Let's say them again. Aka, ao, ki, midori. Now that you've learned the pronunciations, let's learn what each of them mean. Aka means red. Ao means blue. Ki means yellow. Midori means green. Now, let's see if you can match each Japanese word to its corresponding color. Please pause the video to see if you can match the word to its corresponding color. So, how did you do? Maybe you did great. However, if you're anything like us, you're probably feeling pretty frustrated. I mean, it was only 4 new terms with 4 different colors that you've been very familiar with since you've been a child. So, why did it take so much brain power to learn this new information? My name is Dustin Crump, and I would like to say thank you for tuning in to our presentation created by my partners Ali, Patrick, and I. Today, I'll be discussing what the contiguity principle is, the different types of contiguity, and how applying the contiguity principle can affect learning when using multimedia. The information which I'm presenting on can be found in Chapter 5 of the text E-Learning in the Science of Instruction, written by Ruth Colvin Clark and Richard E. Mayer. During this presentation, we will explore the contiguity principle, and at the end, you will be able to identify when the contiguity principle is being used, and you will also be able to distinguish between the different ways in which the contiguity principle can be applied when using multimedia for instruction. So, how do people learn from images? Before we begin, it's important to understand this. Learning through images involves our sensory memory paying attention to an image. Then, that information is transferred to our limited working memory. Our working memory has a general rule, 7 plus or minus 2. This means that most adults can hold only 5 to 9 items in their working or short-term memory. It is during this phase in which the adult memory retrieves previous knowledge and meets new information in which they are learning. This is how information is learned and therefore transferred to the long-term memory. Another important concept to understand before we dive deeper is what the word contiguity actually means. According to the Oxford Dictionary, the psychological definition for contiguity is defined as the sequential occurrence or proximity of stimulus and response causing their association in the mind. Okay, on this slide, I want you to begin thinking about the contiguity principle by asking you the following questions about this image. Number 1, is the contiguity principle being applied? If so, how? Please pause the video to think about the questions. If you answered no, you're correct. In this slide, the contiguity principle is not being applied. Let's discover why. Clark and Meyer define the spatial contiguity principle by stating that learning from corresponding text and graphics is better when the corresponding text and graphics are presented near each other. Okay, so on this slide, the contiguity principle is broken. This map was made with each of the different states labeled with the letters A through E. At the upper right, the letters were displayed with their corresponding state on the map. So, what's the problem? When learners are presented with a diagram with labels and a legend, such as the one above, their working memory is being exhausted by their eyes navigating back and forth from the map to the labels on the image. Therefore, an optimal learning environment is being compromised. So, as future instructional designers, it's important for us to be able to imagine how we could redesign this slide without compromising the multimedia principle. What I would like for you to do now is to pause the video and consider how we could redesign this slide with the contiguity principle in mind. If we were to try and fit the names of the different states into the image of the corresponding state, it's possible that the text would become so small that learners may be unable to read it. So, we decided to type the names near the states, then provide arrows to each of the corresponding states. By doing this, we're ensuring that the working memory is not being used to scan from a legend to the corresponding labels, but instead is being used to easily identify the location of each of the states. But how do we know this is true? There have been several research studies that have helped professionals support the claim in which the spatial contiguity claims. For example, according to page 101 of the textbook, in 5 different tests involving lessons on lightning formation and how cars' braking system works, learners received printed texts and illustrations containing several different frames or on-screen text with animation. For the integrated group of learners, text was placed near the part of the illustration that is described. For the separated group, the same text was placed under the illustrated as a caption, as we'll see on the upcoming 2 slides. Across 5 studies, the integrated group performed better on the problem-solving transfer tests than on the separated group. Overall, the integrated group produced between 43 and 89% more solutions than the separated group. As you see in the image on the left, the text is placed to the left of the corresponding lightning image. In the image on the right, the text is placed at the bottom rather than next to the corresponding image. The learners acquired more knowledge from the image on the left than from the image on the right. Both of these images represent how a hydraulic braking system works. In the image on the left, the text is placed beneath each image in which it attempts to explain. The right image lists a full sentence of text beneath the 2 different sections of the hydraulic braking system. Learners who were exposed to the image on the left, when assessed, scored significantly higher than the learners who were exposed to the image on the right, as we mentioned before. Additional evidence comes from eye-tracking studies involving text and corresponding diagrams. Successful learners tended to read a portion of the text, then search for the object being described in the text, then read the next portion of the text, and search the diagram for the object being described, and so on. A few common violations of the spatial contiguity principle mentioned in the textbook are separation of text and graphics on scrolling screens, separation of feedback from questions or responses, separating content with linked windows, presenting exercise directions separate from the exercise, displaying captions at the bottom of screens, using a legend to indicate parts of a graphic, and displaying running text in a separate window with animations or video. So, now that we've discussed the contiguity principle that focuses on visual information, let's learn a little bit more about the brain. First of all, you need to be able to identify the parts of the brain, as you will see on the upcoming slide. Letter A is the frontal lobe, B is the temporal lobe, C is the pons, D is the medulla oblongata, E is the parietal lobe, F is the occipital lobe, and G is the cerebellum. And here's an image of the location of each of those terms. Okay, chances are you may be a little frustrated again. Perhaps you're asking yourself, why didn't they put the different parts of the brain on the same slide? Well, that brings us to our second contiguity principle, which is the temporal contiguity principle. Our textbook defines the temporal contiguity principle as learning from corresponding text and graphics is better when the corresponding text and graphics are presented simultaneously rather than consecutively. So, perhaps this would be a better way of presenting information about the brain. Letter A is the frontal lobe, B is the temporal lobe, C is the pons, D is the medulla oblongata, E is the parietal lobe, F is the occipital lobe, and G is the cerebellum. And in our opinions, applying the spatial contiguity principle for this image is more effective than applying the temporal contiguity principle, or spoken words, as we did in the previous slide. So, let's recap. The spatial contiguity principle needs to be applied when we are reading text while also learning from an image. The spatial contiguity principle claims that text that is presented needs to be positioned close to its corresponding images. The temporal contiguity principle needs to be applied when we're reviewing an image but listening to the information about the image. The temporal contiguity principle claims that narrated words should be presented simultaneously with the images in which the words are describing. In a recent study across 9 different experimental comparisons involving pumps, brakes, lightning, lungs, and musical notation, in every experiment, students who received simultaneous presentations performed better on a transfer test than did students who received a separated presentation, yielding a median effect size greater than 1, which is considered large. Now, let's revisit the lesson on colors in Japanese from the beginning of the presentation. The first time the new Japanese colors were presented, the words were presented to you alone, yet narrated by me. The second slide included the colors, but no words. Therefore, the spatial contiguity principle was violated, being that the words were not presented along with their corresponding images. Here is a more effective way of exposing you to those words in which the spatial contiguity principle is applied. So, let's see what you've learned. The next slides will demonstrate the different contiguity principles. Feel free to pause the video in each slide if needed. So, is the contiguity principle applied or violated? The contiguity principle is violated because there's a legend on the right side of the screen with corresponding numbers throughout the skull on the left. In which one is the contiguity principle being applied? Option 1 or option 2? Option 2 is correct. In which of the images below is the contiguity principle being applied? Option 1 is correct. In which of the following images is the contiguity principle being applied? Option 1 is correct. So, what don't we know about contiguity? So, one thing that we don't know is how many words should be in each segment. Another thing we don't know is, does the contiguity principle go away or does it not exist when the verbal message is very short, such as just a few words? So we hope that you now feel more comfortable identifying ways of using the spatial and temporal contiguity principles. Thank you for watching.